Buenos días. Welcome everyone. Guten Tag. Tenemos hoy el placer de tener este seminario. We have this seminar today with Max Hille, Hillebrand, who is a professor in the Master Bitcoin, the English edition, and who, from what I've seen, is a very passionate person when it comes to liberty, technology, scarcity or non-scarcity,
Yeah.
and who has offered this conversation about privacy and
Yeah.
Bitcoin and Bitcoin. So thank you so much.
Thanks for
Matt,
having me.
for doing that. I have to recognize I understood like a 10% of what I read, and hopefully I will understand more after the conversation.
Yes, yes. I have a mic, so I very much like doing interactive sessions, Socratic style. So let's just have a proper conversation. I hope that the audience here can speak as well. Do we have a speaker here? Okay, cool. So yeah, just talk when you feel like it's interesting. Yeah, and so I'm not sure about what your current level of understanding of Bitcoin is. You said you're a bit on the early stages. How about you?
Also basic.
Basic, yeah.
I more or less understand it. I own a bit of Bitcoin.
Yeah.
Yeah.
Yeah. Cool. Because the initial text I sent you was specific about the privacy of Bitcoin.
Yeah.
Maybe that's then a bit too in the weeds. Maybe we can start more with a general introduction to Bitcoin and how it works, what it means. Right? So, how much or what do you think about the history of digital money? Is it something that you've ever considered, like when the first digital payment systems came around?
I don't know too much about it.
Yeah. When do you think were the first digital payment systems introduced? Yes.
You mean something like, well,
PayPal, right? That was when was that? Maybe like 2090? Yeah, like
because
90s.
it was there in 2000.
Yeah. Yeah. Oh, take the microphones, please.
yeah.
Yeah.
Like it's late
Can,
90s.
can you hear can you hear us talk from
Yes.
Yes, we can.
Yes.
okay, great.
Nice.
I thought there was some work done in the 1990s even before,
1990s.
maybe even 80s. There was some early work done or efforts to do digital cash.
Yeah, exactly.
I,
I think the first real like academic paper was from 1983 by David Chom. It had a great title, something like Anonymous Digital Payments, How to Make Big Brother Obsolete. Something like this was quite a provocative title. And like this guy figured out not just how to make like payments online, but how to make them fully anonymous, which I think is really interesting. Because the crew that kind of started this whole thing was the cypherpunks. And they were extremely interested in bringing freedom to the digital realm and doing that through anonymity and privacy preserving transactions. And so the first payment mechanisms were actually private. And that was before the internet even existed. Like the internet is like end of the 90s. And David Chom then built a company where he tried to have these digital payment systems as a service. Unfortunately, he went bankrupt. And that's why the whole idea kind of died out and fizzled out there. But so what do you think is important aspects of a digital money? Like what's needed if you would want to create a digital money? What type of things do you need to worry about? Yeah. Yep. So no third party to guarantee the process. Yeah. That would be nice, but that turns out to be super hard, right? So the eCash, Xiaomi and eCash that had a third party, specifically one server, right? So there was one computer, and if that computer was working, everything was fine. If that computer gets shut down, the entire system dies. Right? And that like centralized systems are easy to build in the internet, right?
Okay, then demonstrated with no double Spending?
Double spending. Yeah. So why is double spending a problem?
Because the double spending is possible. The cost of the money itself disappears after a few weeks of great consequences for happening and value.
Yeah.
Hey, Max, we can hear you well, but we can't hear the other participants. I don't know
Yes.
if they could use
Sorry.
the microphone
Yeah,
maybe
double
when they're
spending.
talking.
Double spending. The importance of double spending. Oh, I mean, catching double spending or avoiding double spending.
Yeah.
Yes.
Yeah, so you linked it a bit to the value of the money. Like, why is it that the value of the money would go down if we can double spend it?
Because it's like counterfeiting, right?
Counterfeiting, that's one way of putting it, yeah.
Exactly. That's what I was about to say.
Yeah. Yeah.
Besides, maybe traceability of the
Uh-huh.
transaction would be nice to have.
Yeah. Yep. So like the counterfeiting aspect of the double spending is basically inflation, right? If I have a token and I give it to you, and then later I turn around and give the same token to you, and then later to you, and then to you, and then everyone gets, I started with one token, but now I can make 100 payments, right? That's inflation. And if we increase the supply of money, given the demand would stay constant, price goes down, and that's obvious. And so we would like to have a digital money that cannot be inflated, right? At least not by everyone, right? If everyone can inflate it, then we'll have too much units of money. Maybe some inflation is okay, but we at least want to be able to control that. Right? And so without double spending protections, we cannot really do that. And so what are some ways that we can fix double spending?
I think a public ledger is part of that, because if everybody can see all the transactions, then we can make sure that it's not being double spent.
Yeah. So that goes back to what you said, right? The traceability of it. How can we find out which transaction came first? We have a record and we say, okay, this transaction came first, this one came second, so this one is invalid, the first one is valid, ignore the other one. Right? And having that in a public ledger is interesting, right? But do you think that we need a public ledger for that? Like, why not?
Oh. No, I don't think we need a public ledger.
Yeah.
But then you have another agent you have to trust.
Exactly. Right. So the Chom's original thing, he didn't have a public ledger. There was one server, and that server had its own internal ledger of like, this token is already spent. Right? So disregard it the second time. But that was not public. So you as an individual user could not verify for yourself if that token was spent already. You had to go to the mint, to that server, and ask, hey, is that token spent? If he says no, then you're like, okay, cool, I'd like to spend it. But ultimately, you don't need a public ledger for it.
Do you need, though, for transparency, do you need an open source software so that what's on that server, you know what's running, so you can inspect and verify the code? And if you're not a programmer, you can't do it, but maybe you could trust people that are programmers that can look at that code, that have good reputation, and say, yeah, this thing is set up in a way that you can't double spend.
Yeah. No, that's a really good point. Like, is it required? I'm not so sure. I think you could have the system work without it being open source code, but it would be less trustworthy, right? You wouldn't really know for sure how the system works. But then, even if the code is open source, do you think that that's enough? Like, if you could read some code on the internet and see, like, okay, this code works properly, would that be enough to make you trust one specific system?
Tough question.
Like, how would you know that this bank, this service, is running exactly that code that you found online?
I don't know.
Well, maybe because it would be verifiable by a lot of other people besides you, like in the blockchain.
Yeah. So like, there's there's one thing of being able to verify the code and read the code, right? And that we can do with open source software. Yeah. Michael.
But your point, Max, you're saying, how do we know that that version of the code is what's actually running on that one central server at that point?
Exactly. And that's a super difficult question to answer, actually. Like, how can we trust what software is running on that computer over there? If we could trust and know for sure and verify that this is the software that's running on this machine, a whole bunch of things would be possible. But it's really difficult to do that.
I know nothing about cryptography, but if by running it, it produces a signal that is recognizable to you, would it be possible to verify that they're running it, the authentic one and not another one?
Yeah. Yeah.
So I noticed the word trust is being used a lot, but it would only come up if we don't trust each other. So then you need to have a system in which you can build trust, but the trust doesn't depend upon human beings. Is that the case, or is that not the case?
Yeah, basically, right? If you can verify something, you don't really need to trust that it's correct. And like computers are very predictable machines, right? If you know the program and you know the input, then the output is always the same, right? But humans are different.
Well, I'm trying to disassociate what I know about Bitcoin from this conversation for a minute and just like have a hypothetical exercise. What if the government had wanted to create this digital cash that you're talking about? And how would we trust that? How would they go about doing it? And I don't know that there's a way to trust that at any point, in regards to what your political views are or whether you trust governments or not. I just can't think of a mechanism where, like, it's almost like a CBDC where the central bank is issuing a digital currency. We still have to trust 100% that they're not inflating it. They're not, like all the characteristics of it, all the things we're talking about are there. And I don't know how you do that. Just, it seems like an impossible possibility.
Yeah, I guess the question is, could they prove it to us? Like, could they prove to us what's running on their computers? And that the same software will be running in the future as well. That's kind of what would have to be required. And that's really difficult. But there is actually, and that's a rather recent like computer science invention, there is a way that a computer can prove to you what software is running. And like there's two aspects to it. First, the computer needs to prove what type of hardware it is. So for example, if you use Intel SGX or like NVIDIA, I forgot the exact name of it, but different producers have these type of what they call secure enclaves, where there is a private key in the computer chip itself. And when the chip is manufactured, NVIDIA or Intel, whatever, takes this key and signs off on it. And so basically Intel is asserting that, hey, the chip that knows this private key, that comes from us, right? And we've produced it. And at the factory, we've signed off on the public key. And now you know the exact version of the hardware that is running there. And so that's the first step that you need to do. Make sure that you know the hardware that is running on this computer. And then the second thing that you can do is that then this chip will sign off on exactly the software that is running in it. And so you know this is the program that is running on this chip. And the chip will produce a signature with the private key that is in it and send it over to you via, to your phone. And then your phone could only continue talking to this computer if the signature checks out and the software that it points to is the one that you expect. Right? So these are trusted execution environments or secure enclaves. They're actually quite common. So for example, in Signal, they use this, the chat app. Right? If you're looking up for a phone number and want to see if that's part of the Signal community or the Signal user base, that actually runs in this trusted execution environment. And your Signal app checks, okay, is this the chip produced from Intel? Is this the software that I'm expecting it to run? And if yes, then it asks, okay, is this phone number part of a Signal user? And then the software will respond yes or no, and these are his public keys, and respond to the phone. But this only happens if your phone has verified the exact piece of software that's running on Signal's machine. And if they would change it to some other software that would spy on all the phone numbers, for example, your phone wouldn't send the query anymore. So we can actually now, with some trust assumptions in the hardware provider, but we can now find out what is the software that's running on someone else's machine. And if we would then run something like a Chongyun eCache mint, or like Cashew, Fedimint, these are like the modern implementations of this, we could actually have quite hard guarantees that, okay, this software that is running on the server cannot inflate the money supply. And it cannot censor individual transactions, and it's not logging any privacy sensitive information. That's actually possible now. But would that be enough to make a good money system? Like, even if we would know exactly what the operator is running on this machine, what's still kind of missing to make it even better?
I just have one quick question before your question. As Gabriel said, I don't know much about cryptography, and I know a lot less than he does. But this verification process uses some kind of encryption so that it is difficult or impossible to spoof it? Or is there a system which is impossible to spoof, or is it just extremely difficult? That's what we're relying on.
Technically, it's extremely difficult. Not like 100%, but like 99.999999999, many nines, so that the residual mathematical leftover is so tiny that even if for the entire age of the universe, we would just spend our energy on trying to get to that last digit, we couldn't, right? So cryptography is very, very rarely 100%. It's usually a probabilistic thing where the leftover probability is so negligible that we just say, okay, it's basically bulletproof.
Max, I just want to confirm this sort of this sort of implementation of a trusted software that requires the software to be 100% open source, right?
Yes, because if the server would prove to you, hey, I'm running this binary blob of data, like this is my program, I'm not going to tell you the source code of it, right? Just that this is the binary like assembly computer code itself that humans cannot really read. Then what have you proven? Or like, you know, you're running this program, but I don't know what the program is, so I'm not happy with that proof. So this only works for open source code.
And not open source, but it has to be like completely 100% open source, because there are unfortunately projects out there that claim open sourceness, but you know, may sometime, I mean, well, even unfortunately, for better or for worse, Trezor has had to also use some open source or non closed source parts, but our workaround is that we specifically avoid storing private keys on those parts, or Bitcoin private keys, I should say.
Yeah, like software has very, very deep production status. Like very rarely does one person or one team build the entire software stack. Like that's kind of impossible. It's like the iPencil of software. Like you cannot write a simple calculator app by yourself. It's not possible because it's way too complex.
Yeah, and it's also at this point probably impossible for anyone to verify all the basic tenets of software and hardware just because of how complex it is inherently, I would say.
Yeah, exactly. And even with these trusted execution environments and secure enclaves, like they have been broken in the past, multiple times actually, because it's just hard and someone will find an exploit. And then especially for these hardware things, it's difficult because it's hardware. You cannot update the hardware of the chip. Like you have to toss it away and build a new one, basically. So if they find a critical security exploit in these designs, then the hardware is screwed, basically.
Yeah, I mean, From my perspective, being in this business, most of the challenge is much more, I mean, hardware is amazingly cheap to manufacture these days, but there's all the problems of the logistics and also just having stock in general it's
Yep.
challenging.
Yep.
Yeah.
So Max, you asked what else we might need for this a minute ago. What came to mind is user tools, whether applications, like how does one get access to this digital currency that we're hypothetically talking about? Because, cash, if you think about physical cash, it's very easy, right? You have bills, euros, dollars, whatever fiat currency it is today, and I can keep those in my pocket. I can walk around, I can pull them out, I can make change, I can pay for things. If I paid, if a $20 bill, I can get the change back. And you have to recreate somehow a similar experience in a digital structure. So we've been talking more about the infrastructure and how do we create a non-trusted way of knowing that the currency is like that the bills in my pocket are really real. They're not, counterfeit, kind of is the analogy. But here it's how do I interact with that currency? And I think it has to be easy. It has to be ubiquitous. It has to be everywhere for anybody, anytime, is what comes to mind.
Yeah, absolutely. Like if we would have a server that builds the server side of the money system, but then there is no user-facing application, like no website or no app to download, then how are you going to talk to the server to move the money? Absolutely. Yeah. What
And
else
interact with each other, I guess, too, because use of money, if you're not using it to just store value, but you're using it for exchange, the other party has to be able to interact with you. And so do you have one, I'll call it a wallet, just because that's kind of what we say. I mean, that's the metaphor in cash is we have cash in a wallet, right? So how does the other person's wallet interact with my wallet?
Yeah, exactly.
And is there only one, or is there a variety of wallets that are interchangeable that can talk to each other?
Yep. Yeah, like how decentralized is that ecosystem basically? Right? Is there just the implementation of the company? And that was, for example, the case with David Chom's original company, DigiCash. Right? I'm not sure if they were open source. DigiCash, yeah. He started that like 1993 and they went bankrupt 1998 or something. Yeah. They got close, like they almost had deals with Deutsche Bank, Microsoft, like big players, but then for a couple of reasons didn't work out. But yeah, the problem, again, I'm not quite sure, but let's say that this was closed source proprietary code, right? The company goes bankrupt. Now what do? Like your wallet interface is gone, your server implementation is gone. Not just that specific.
Well, did you just lose your money too? If you had money in there, it's gone, right?
And so that comes back to even if we would have a fully verifiable server where we know exactly what is running, right? What happens if that server gets pulled the plug? Right? If the money lives in that one machine, then it's gone. Right? And that was the problem with centralized digital currencies in the past. There were many attempts like Liberty Reserve, eGold, a couple others. They were all centralized. There was one computer that had the history of the transactions and that was checking the double spending, that had the power to create new tokens and so on. If that one server dies, for whatever reason, there's a myriad of reasons for why it might die, then it's gone. Right? So the goal of Satoshi was to create a digital money system that distributes that responsibility of keeping the system alive to more than just one person or one server. And that's what the idea of a decentralized money is, that it becomes censorship resistant in the full aspect of nobody can shut it down. And if you would want to shut it down, you need to shut down every server that runs the software. And if hundreds of thousands of servers run the software, it's for all intents and purposes to 0.0001 whatever, right? Unstoppable. And that's what Satoshi achieved ultimately.
That's one of the reasons why it's so important. I mean, there's a lot of argument in the Bitcoin space today about spam and different things, but it's really about block size and how easy it is to run one of those little servers that you're talking about. Because if you have to be an institution to run it, you're back to trusting institutions versus being able as an individual to spin up your own little version of the server.
Yeah, exactly. Like that was the whole ordeal of the block size wars. Of like, some people are saying, hey, we can just make way more transactions if we increase the size of the blocks. I just increase throughput. We'll be super cheap. We can have millions of transactions per second. We'll make PayPal and Visa obsolete. That was the one side of the argument. And the other side of the argument was, wait a second. In Bitcoin system, you need to verify every transaction of everyone else in order to verify the payment that you receive. Right? If I want to receive a coin, I need to check, was this double spent by anyone else before? And so in Bitcoin's design, I need to verify every transaction of everyone else. If that becomes very expensive and it takes me months or supercomputers in order to figure that out, then all of a sudden I'm back to having to ask that guy over there that has the supercomputer with like, hey, is this coin valid? Has it been double spent? Etc. And then we're back to the problem of now I have to trust this guy for one, to be honest, and maybe we can use some fancy cryptography and proofs and stuff to reduce that part of the trust. But what if he gets shut out, right? Someone pulls his plug. Now I have to trust one of the other guys. What if all of them get shut off? Then the system is dead again. So with Bitcoin, the idea is really that the end user, the merchant who sells pizza, right, he ought to verify the entire monetary system so that he can receive cash completely trustlessly. Just like a bar of gold, you see it, you check it, you bite it, right? You ring it. That's where sound money comes from, right? You flip it, and the sound that it makes is the verification of the purity of the gold. Right? To get sound money, you have to verify it. And if we want to verify it self-sovereignly, then in Bitcoin's design, at least, we need to verify every transaction of everyone else. But so maybe to bring that then a little bit to the topic of the chapters I sent out, like, then how about the privacy of that system? Like in Bitcoin space design, is that a good design in terms of privacy?
Sorry.
So what I was going to say is, obviously, in the blockchain, you can see all the transactions, and maybe I'm getting a little bit ahead here, but one of the companies that or projects I'm working on, we received our first Bitcoin payment from a client. And I won't mention the name of the company, but it's one that we would all know, and it's actually in the space that we've just been talking about. And it was fascinating to me when I went on the chain and looked at that payment. And by the way, prior to this, I've only moved money between my own exchanges, my own wallets. Everything's been my own transactions, right? And I do some mining, so I've gotten some from the pool. But this is the first transaction I got from a client, and it was fascinating. When I went and looked at it, I could see the wallet address that they sent the payment from. I immediately could see how much Bitcoin is in that wallet, and I could, through the mempool, .guide or .space, whatever your favorite tool is, I could go then start to trace backwards and see, where did they get that money and where did it come from? And I'm not doing chain analysis. I'm not like at that level, but it was very fascinating to me. All of a sudden, I now know, at least to some degree, how much Bitcoin my client has.
Yeah.
And that was like eye-opening to me, like, oh, this privacy thing is really an issue. Like, it's really cool that I know that the Bitcoin they sent me for the payment is real. It's not double spent. I know I can verify it. But at the same time, it exposed an awful lot of privacy that I started thinking about. The same company's going to start making payments. How do I need to organize my own, Bitcoin accounts and wallets and UTXOs so that I'm not exposing too much of my own private information to my vendors that I'm paying? It was different than just playing around with Bitcoin, right? You actually use it as money. And it was fascinating because this just happened last week, and I was thinking about this seminar we're doing and wondering, like, what's the solution to that?
Yeah, that's you put your hand exactly on the root of the problem. Like there's dragnet surveillance and like surveillance companies checking every transaction and stuff, and that's That's a problem. But I think the much more pressing problem is that the sender can spy on the receiver and the receiver can spy on the sender. And like, that's just a bad idea for many, many, many reasons. Like, imagine your employees know exactly how much you pay each of them, right? And all of a sudden they, can complain, oh, why does that guy get more than me? And things like this, right? What if you make a gift to one of your kids and now all of a sudden he sees how much money you have, right? Maybe that's not information that you actually want them to have, right? So there's
Right.
a myriad of different reasons why this is a really bad idea. Yeah. It's like, how can we think about solving this? Like, now we've identified the problem. What do we do about it?
Well, this is where your paper was super complex. There's a lot in there. And to be honest, I ran it through AI to give me a summary and kind of help me with the points.
Good.
And so I got some out of it what you were saying, but all of those seem like complex solutions to me to implement. And maybe it's just because it was my first exposure to thinking about that, but it wasn't immediately obvious to me how to solve that problem. Yes, you could do coin joins. Yes, you could do this and that. But you can use different addresses. But even then, I don't know. It didn't seem like there was an easy answer to the problem yet.
I mean, you brought up one, which is kind of the baseline of like, don't reuse addresses. Like, what's the problem with reusing addresses in the first place?
Well, you can see all the transaction history if you go in the mempool or on the chain. You can see every transaction. You can see the balance of that address. You can also look at every transaction that's ever happened with that address, which tells you a lot of information. So by not you reusing the address, I guess it's a one-time transaction essentially. So you can see that one transaction, but you can't see the rest.
Exactly, right. And like the investigative work that you did, where you have to check the previous transaction and see if that might be the person. But if that person is always reusing the same address, you have like a proof of like every payment that goes into that address and that goes out of that address is from the same guy because it's one private key protecting it. But if you would be using a fresh address each time, then you're not sure if that transaction that paid him is like some other merchant or like some other party, or if it is the change of the same user, right? So just by not reusing addresses and always getting a fresh one, you add a little bit of ambiguity for every transaction that happens, right? It might be the same guy, but maybe not. And even if it's just a little bit ambiguity, after enough many hops, that becomes quite a lot of uncertainty. And so this is the first part of it. What are some other?
What are the tools you can use? Like, I don't know how deep you want to go in the weeds, but if I wanted to not reuse an address, what are the tools or the best practices to do that today? Because a lot of times, especially with exchanges, they control all of that, obviously. But if you're in full self-custody, using your own, say, Treasure wallet or whatever, what's the best practice? How do you mechanically do that, I guess is my question.
Yeah, I guess it really is just up to the wallet to do that properly. Like some early Bitcoin wallets, whenever you clicked on receive, it showed the same one address. Right?
Mm-hmm.
But most modern wallets, basically all of them, if you click receive, it will be a different address than the last time you clicked receive.
Mm-hmm.
That wallet in the background manages all the hundreds of addresses that were generated across the lifetime.
Mm-hmm.
But for you, it's just clicking receive, and that happens, right?
I was going to ask, is it Sadja or Nick? I think you go by Nick.
Yeah.
Is that right?
Yeah.
Okay, Nick. Since you're with Treasure, I'm curious if I have a Treasure wallet, which I do, I use them, and I spend, and then I have change. Do you automatically generate a different address for the change?
If you are
From the
using
transaction?
Trezor Suite, yes. So the
Okay.
fun thing about Trezor on a really nitty-gritty level is that there's kind of to get really technical here, there's the device and then there's the software, okay? you have our device, but you're not actually required to use our software. Our software
Right.
is,
I can use it with Sparrow or whatever.
yeah.
Yeah.
Yeah. So if you're using Sparrow, then Sparrow decides, are you going to use a change address or are you going to use something else? You can also, if you want, Roark, right?
Rourke, yes.
Roark, sorry, yeah. If you want to manually create your own change address, you have that option because Bitcoin, any good Bitcoin wallet should be able to handle multiple outputs. So you got a lot of different options. But by default, the software we developed that accompanies a Trezor hardware wallet gives you a change
It
address.
does change it, just change it. Okay.
Yeah.
But I have to be more aware of it if I'm using another software with a hardware wallet.
You just need to
And
check
manage
that
it.
it's set up properly, and Sparrow, Electrum, in my view, I think
Yeah.
they're pretty reliable Bitcoin wallets.
Honestly, I don't know of a wallet that doesn't generate new addresses nowadays. Like it's very, very rare.
Yeah.
So like
You're saying, Max, it's rare that they do not do what Nick is describing.
exactly. So like every modern wallet creates new addresses. Like exchanges are the most guilty for this. They very often mandate that you have one address to deposit the money into all the
Right.
time. Right. And that's just because they're stupid and bogged down by regulators. Basically.
I think the reason that wallets would have historically not done change address generation was because we didn't have really, well, any sort of seed phrase until 2013, 2012, 2013, 2014. And
Talk a bit
if
more
you,
about that.
yeah, so
With the backups of the past and how these new phrases fixed up.
yeah, so basically the original Bitcoin QT client by Satoshi, that was generating new private keys whenever you wanted it to. And this is a problem because you really only want to generate your private keys one time. If you generate new private keys whenever you need them, you have to back them up. And it didn't have a way of backing them up. The reason we use seed phrases today, or it's technically a seed plus a mnemonic phrase that represents that. The reason we do that is so that we only have to generate your private keys one time. So there is a system that was developed back in 2012 that said we can take a piece of data and we can use it to safely generate private keys and addresses that are unrelated to each other. And that has been extremely helpful to Bitcoin privacy because now I only have to generate my private keys one time and I have anything I will ever need. I have way more private keys than I could even probably publish Bitcoin transactions for.
Yeah, exactly. And so there's one other, like the use case we talked about now was someone asks you, hey, I want to pay you. So you go to your wallet, click receive, give him a new address. The other main reason nowadays why people reuse addresses is, for example, donations. Right? On your Twitter profile, you put one Bitcoin address there and hope that someone sends you money to it. But this is static, right? So Twitter doesn't know that you got paid and it's not automatically giving a new second address into your profile. And so for this reason, BTC Pay Server was developed, basically. So with BTC Pay Server, that's a server application that you run on your own machine. And it has a Bitcoin wallet, it has a Bitcoin full node, and a nice website interface. So that you can, whenever someone clicks, hey, I want to pay you money, it actually generates a new address for this one-time use case, shows it to the person who wants to send the money. And as soon as money arrives, confetti and thank you, and here's the product that you're buying. And so BTC Pay is a wallet designed for a server so that you can have one static URL, like pay@me.com, whatever. And then BTC Pay as a server wallet application will do the trick of generating new addresses for you every time.
I just wanted to say something. I see that this, say, responsibility is delegated to I mean, third parties, not the actual blockchain. those are layers of security that are not inherent of the blockchain. How can we even, I mean, I don't know how to ask the question, but there are so many possibilities here, so many wallets and so on, that how are we sure that these are legit wallets or something?
Yeah.
Is it embedded in the blockchain? I mean, I think that's the answer, no?
Yeah, I think what you're pointing to is like this question of there's a really good research paper called Anonymity Loves Company from the 2000s, written by the Tor team. Really, really great. And their main point is that if we want to have a secure system, in their case specifically a private system, making the right decision on how to design the system is really, really difficult. And if we put this decision-making responsibility to the end user and ask the end user questions like, okay, so what key size do you want to have? Like, which nonce generation would you prefer? Like, what should be the entry node to the PGB or to the BGP, routing protocol? Like all these crazy questions, the user is the least capable of making educated, good decisions here. And so it would be better if the user-facing wallet or like application software developer makes that decision. So in our case, the wallet developer should make the decision to not reuse addresses. And then if he does, the user doesn't have to worry about this. But even the software developer might not be the right one to make this decision. It would be better if, for example, the library developer makes that decision. So that if you make the pretty user interface, all you have to do is call the library with get address, and it will give you a fresh address. So even the wallet developer doesn't have to worry because the library developer did it. But we can go even further down the production stages to things like, okay, the protocol designer should worry about these questions. And so the point more than economic lens is the earlier in the production stages we solve the problem, the better it is, because everyone who's downstream of that earlier production stage will have a correct decision made. And I think that's what you're kind of pointing to. It would be much better if Satoshi would have had a protocol that doesn't have to worry about like address generation and coin selection and all of these other things. If the protocol would have solved all of these problems, none of the people that use the protocol would have any issues. Right? It's just hard. Yeah. The problem is just it's like almost impossible. And so Satoshi had no idea. Like it was the iPencil problem. Like he couldn't possibly have produced a pencil. And like he barely made something that can scratch on a paper. But in order to have a proper ballpoint pen, we need way more production than just this one dude in his basement trying to figure it out.
I think, Max, like for me, one of the classic examples of the sort of things that Bitcoin enforces for people is the 128-bit cryptography of its private keys, which is a very reliable, but also, at least by today's standards, I think it's kind of the most basic security you can have that is considered reliable, which is to say insanely foolproof, minus the quantum issue, but also we never know what's going to come up in the future, so we just assume it's foolproof right now. And by the way, this is not me saying this. This is actually the U.S. government that says it's basically something called Category 1 security, which is basically we say this is reliable at this time, and that is what is used in Bitcoin. It could use stronger cryptography. It does not, because that's going to actually just take up, first of all, it's going to take up more block space if you use stronger cryptography. So your transaction throughput goes down automatically. But again, this is both a standard set by the US government and by what's called the National Institutes for Standards and Technology, or NIST. And then because it's an open source standard, it's widely verified by developers. So this is a very complicated thing to explain, maybe politically, but it is how it works.
Yeah. And so to look a little bit back to your question of like how can we actually like solve this problem properly? I think in Bitcoin's practical reality, this is very much up to the wallet developer. Like the wallet developer can make Bitcoin secure and anonymous and instant and cheap. Like all of these things that the Bitcoin base layer protocol does not do, we can fix at higher layers. So for privacy, like, I mean, the paper I sent you has like many thoughts, but the simple answer is just use Wasabi wallet and you'll use Bitcoin anonymously. Like that's the simple solution of use a wallet that was designed from the ground up to be privacy maximizing, and you'll be good. If you want to use worry a lot about hacking and stuff, use Trezor Suite. They've designed both hardware and software to make it really, really difficult to hack your Bitcoin. So a lot of these things can be solved at the wallet layer ultimately. And so there's a lot of trust and responsibility in the wallet developers. And then the question is, how do you find the right wallet? And that's a difficult question. That's like, gotta do your research, listen to what other people think, right? Watch the market for like track record. Like Trezor hasn't really been hacked. So Trezor users, the like architecture of Trezor wallets, right, haven't really been hacked, etc. So they're probably good for another 10, 20 years. It wouldn't be effective.
Yeah, other than a specific vulnerability in 2020 with the original model, a couple of vulnerabilities, but these have been patched. So as long as you are using up-to-date firmware, it is not. None of our products are hackable, to our knowledge.
Yeah.
I want to just bring the discussion a little bit more out of the technical issues and talk about a little bit of the philosophy of trust, because we are mentioning trust and there are lots of people that are not in a Bitcoin but heard of it and they don't know what to trust. They don't know which resources to trust, and if even to trust Bitcoin. What do you think, Max, is the features of Bitcoin making it trustable? What are the things that should convince people why they should trust better into decentralized monetary system than the centralized one?
That's a really good question. And I think to a large extent, what Bitcoin showed us all that is possible is not quite even related to trust. So maybe I'm walking around your question, but what Bitcoin taught me is that you can define for yourself the rules of your money system. Like we're all just used to using the euro, dollar, whatever, right? We don't even know what the rules of that money system are. And someone else designs them and someone else can change them, and they do. They increase the money supply constantly at very unpredictable rates. And we were just fine with that for like ever.
Yeah, and we don't have really discussions about how like Swift works or how your Visa card works or NFT, like NFC, if it's secure enough, right?
Yeah. And so maybe the point is that like you don't have to trust other people with things like the rules of your money system. You can just make your own money with the rules that you care about. That's what it means to run a Bitcoin full node. It's to first define the rules of your money, like 21 million Bitcoin, right? Like elliptic curve cryptography, SHA-256 hashing. Like these are all the different building blocks of the rules of the money system that you want, and you can do whatever the fuck you want. If you want to use different hashes, different block times, different money supply, it's just a couple lines of code. Like you can vibe code it. Like you don't even have to code it anymore yourself. Like literally, right? And then once you've defined the rules of the money system that you're happy with, you check about the transactions that are gossiped on the network, and you see if the transactions of other people are valid according to your own set of rules. And if they are valid, you add them to your node and you remember them for later. And if they're invalid, you just delete them. And you never connect to the peer again who gave you an invalid transaction because he tried to cheat you, right? So you define the rules, you verify the rules, and you enforce the rules. And all of this does not require any trusted third-party server. Right? You don't have to outsource this. You don't have to trust it all. This is you for yourself making decision of how do I want my money to work? And then you can just do it. And now that puts a lot of responsibility on you in the sense of there are better and worse rules for a money system. And generally, a money on which rules we all agree on is way more valuable than if it's your beanie baby tokens that you came up with by yourself, right? So that consensus of we all share the same rules of the money makes the money insanely valuable. And that's why a lot of people who tried to create their own money systems and forked Bitcoin dreadfully failed, right? Because what their perceived changes to the set of rules was not meaningfully better compared to what Bitcoin actually offered from the get-go. And then the network effect and the scale of Bitcoin made it very, very difficult to find something that's actually better. And we can point to a lot of nitty-gritty details that we could improve, like making Bitcoin more private, faster, cheaper, all of these. But none of them are a meaningful enough difference to the network effect that we've already built over the last 2 decades.
Something I found very interesting when reading your chapter was that you were mentioning before the more upstream you solve these problems, the better, in the sense that it's like a cascade. And at the same time, one of the things I found really interesting was, I don't remember the name of the solution, but the solution that is really similar to the solution in philanthropy that has been found in philanthropy. So in philanthropy, there was this problem, allow me this diversion here, this problem that many people want to donate to certain causes, but they don't want other people to know that they have donated to certain causes. Mm-hmm. So how can I solve it since my transaction will be seen? I'm speaking about now any money, fiat money, whatever, and my bank transfer. So the solution of that problem was the trust. So there are some trusts where you send the money to that trust, and that trust by another way has your preferences and the money goes out of there. So a lot of things go in, a lot of things go out. It's impossible to know that. And if I understood the paper correctly, down the stream, not up the stream, down the stream, that has been one of the solutions found for privacy in Bitcoin.
Yeah.
Is it correct?
Absolutely. And like an ancient solution from like 2010 or something, like a couple of years after Bitcoin came out, people realized this, like, hey, all the transactions are public. If we want to buy our drugs or whatever, let's get a bit smart about this. And so what they started with were called mixers, which is basically, I'm a service provider. I have a Bitcoin wallet. Now, all of you want to make private transactions. You just send me your Bitcoin. Totally fine. Just give me all your Bitcoin. And I have an Excel sheet of like who sent me how much. And then a couple days, months later, whenever you want to have the money back, trust me, I'll send it back to you. And I'll maybe in between make a bunch of transactions to myself. Like I've become a service provider for making a transaction graph on the blockchain that is more private than any one of you could individually do, either because you don't know how to do it, or just because of the liquidity. The more Bitcoin we have, the more different transactions we have, the the easier it is to create the chaos and confusion on the blockchain to throw off the people who want to spy on it. Right? And that was the very, very early ideas on how to make Bitcoin private. Basically a trust, right? The big problem is you all have to trust me. First of all, exactly, right? Like, first of all, to not run away with your money, which, believe me, happened countless times. Like, there were thousands of these mixers, and most of them ran away with the money, or most of them got hacked. And the ones who didn't got taken down from the government because it's an illegal bank, right? And so the government stole the money. Great. Yeah, exactly. So that was the first problem, right? Just you could lose your money, which sucks. And the second problem is I have that Excel sheet where I see exactly you gave me 10 Bitcoin and then later you send it to that address, right? So you have to trust me with custody and you have to trust me with privacy. And that's not so great. Right? So then the second iteration of blockchain privacy is coin joining, basically, which is ultimately what Wasabi Wallet implements and what's still to this day, I think, the best privacy solution for Bitcoin blockchain. And the idea is, instead of you all sending me the money to my address and then later you tell me to which address you want it to be sent, let's produce one Bitcoin transaction together, right? The Bitcoin transactions have inputs. Those are the coins that are being spent, right? Plus the signatures that prove that you can spend them. And they have outputs, which are the addresses where the money goes to, right? The new owner of the Bitcoin. So and the cool thing is we don't have to, like, it's not an instant process to create this transaction. It can take some time, and that's fine. So me, instead of being the trustee of your money, I'm now just the coordinator. And I have an Excel sheet, let's call it. And you come to me and be like, hey, I want to put 1 Bitcoin into this transaction. I'm like, okay, cool, noted. You want to give 5 Bitcoin in, you want to give 3 Bitcoin in, and what's on, right? Everyone puts the amount of money that they want to put in, and they just tell me, hey, this is the coin that I want to spend. So technically the transaction ID and the index number of the transaction that created the coin on the output side. Right? So you all tell me, hey, these are the coins that we want to spend in this transaction. So far, no money moved. Right? We're preparing the transaction that will move the money. And then on the output side, right now, you can say, hey, I put 3 Bitcoin in, whatever. I want to get 3 times 1 Bitcoin to these 3 addresses. And you all own these addresses. Right? So you're sending money to yourself, but not in a single transaction by yourself with like 1 input, 3 outputs, because that's easy to follow. Right now I know, hey, this 1 input paid these 3 outputs, because that's all that it is in the single user transaction. But if you add your own 2 inputs, 3 outputs, and you have your 3 inputs, 1 output, and you know, everyone has his own inputs and outputs, and we just put them all together, and then we have one large transaction with many inputs and many outputs. And I'm the coordinator, I put it all together, I talk with all of you, and toward the end of the process, I propose to you now, hey, this is the transaction that we're all going to sign, okay? It has 100 inputs, it has 100 outputs. Many of the outputs are even of the exact same amount, for example. And now I propose to you, are you okay with this transaction? Does it have all of the inputs that you wanted? And very importantly, does it have all of the outputs that we wanted? Right? And are the amounts correct? Because if you could put 10 Bitcoin on the input side and 1 Bitcoin on the output side, you're going to lose 9 Bitcoin, right? So you're probably not going to be okay with this. And your wallet first will verify, do I get all my 10 Bitcoin back? And only if yes, if all of the outputs that you want are there, only then will you sign for the 1 or multiple inputs that you have, the entire transaction. And only if all of us sign the exact same transaction, will we have the 100 signatures that we need. And then we can broadcast the transaction to the Bitcoin network. And so that's what a coin join is ultimately, a collaborative Bitcoin transaction, which functions a little bit like a trust, right? Of, okay, we sent the money there and then later it gets sent there. The cool thing is though, it's non-custodial, right? Because if you see that, hey, I put 10 Bitcoin in, I get 1 Bitcoin out, I don't want to send it, then you just walk away. And all this transaction that we worked on becomes useless because it's missing one signature from you. And we need to have 100 out of 100 signatures. And then if any one of us walks away, the rest of us have to try again without you. And until everyone has signed the transaction, and then we can broaden. So this is how we can get anonymity size for the transactions that we do. And quite substantial anonymity.
So the very naive question, but what kinds of transactions am I going to be doing with this? Because to go to an earlier question, as an everyday person, this seems way too complicated, right? Way too complicated. And if I just want some stupid appliance off Amazon or pay my rent or something like this. Now you talked about buying drugs, but I'm assuming that's not exactly you mentioned wanting to have privacy in the donations that you make, which, well, let's go with that, something completely legitimate, right? But you still don't want people observing it, right? It's a matter of privacy. So my question to kind of come back to it is, what kinds of legal transactions, let's say, would one be doing with this? How often? And then maybe the additional question is, if Bitcoin, if its privacy requires this level of complexity, is the vision for it, now I'm getting into a big question, but is the vision for it that it will always exist alongside these very deficient, easy to track, easy to control, easy to wreck monetary systems? Because those are more or less going to dominate in easy everyday transactions no matter what. And then Bitcoin is going to be relegated to more specialized kinds of transactions.
Yeah. I mean, it's like, for example, what Roche was saying earlier, right? Like he got paid for some business that he did, and now he can spy on how much money his customer has, right? Like that's crazy information. The fiat banking system gives you better privacy. Like if you send me a fiat transaction, I have no idea how much money you have, right? And I have no idea where you got it from. And with Bitcoin, even that basic level of decency in terms of you not being completely naked to the world, that's this. So I think that privacy is quite important for many things, and including for economic calculation. And I think with a very surveilled system, we will have massive distortions in prices. And that's the economic take of my book, basically, is a little bit like the Cantillon effect of like prices will be distorted if the money is surveilled or under any type of surveillance. And that just means more boom and bust. Like we will invest in stuff that we wouldn't have invested and way more, and we will neglect to invest in the stuff that we don't need, that we do need. And that's the boom periods. And then at the bust, we have to reallocate those resources to get the things that we actually truly need. So there's many reasons of why privacy is important. They're on the micro level and on the macro level. So ultimately, like I think having privacy for most of the transactions, unless you explicitly want to make a public transaction, is going to lead to more prosperity for the economy as well. And then to your other good question, if we don't solve the problem at a higher stage, right, upstream, then not everyone downstream will have the solution, right? There will be some wallets that reuse addresses, and only a few wallets that implement Tor, or coin joins or whatever it is. And so that means we have less privacy. The anonymity set size is smaller. If we would have solved it earlier in the protocol, everyone would have been protected regardless of what they do. But because in Bitcoin we did not, that means there will always be people who use it the old way, right? The less secure way, the less private way, and then people who use it paranoid style. And maybe that's not so great. Right? That's an argument for a cryptocurrency like, for example, Monero. Right? Monero has as its mission, we want to have the most private system that is practical. And they realized that we cannot set the system in stone, right? We cannot say that Monero will never change. Because if we do that, we fail our mission of having the most practical privacy possible. And that's why Monero every year makes a hard fork, right? And changes the protocol. Because that's required for them to keep improving. but that means it's a less reliable or like less predictable system. Another example is Zcash. It's another very private or attempting to be a very private form of Bitcoin. It's actually a fork of Bitcoin. And so Zcash also has this problem of there's the public pool, which works exactly the same way as Bitcoin, inputs and outputs, and you see the full transaction history. And then they have these shielded pools, which uses some crazy fancy zero knowledge cryptography that they've implemented to make sure that nobody knows the amount or the transaction history of any of these transactions that happen. And they're now in the third edition of these private pools, right? So they also have to keep upgrading the system. But the problem is the very first system, the first shielded pool, what was it called? Sapling? Yeah. Had a critical bug. And there could have been for years undetectable inflation, right? And the developers knew about it and they didn't tell anyone. And in the background, they worked on a fix, right? And trust me, bro, we didn't exploit it. Right? But like, that's the problem with a lot of this cryptography of if it breaks, it can break catastrophically. We also had inflation bugs in Bitcoin. Like in 2010 or something, what was it, like 50 billion Bitcoins were mined in a single transaction. But everyone could see it. Right? Everyone could instantly see, okay, this transaction is clearly broken. Here's the line in the code where it is broken. Let's fix it. We rolled back the blockchain, continued from there on out. If we have some fancy zero knowledge magic in the blockchain, we might never even know that this is happening. And this is exactly the problem that Zcash has. Right? Yes, it's private. It has the private option, not private by default like vanilla. And even just having that option requires you to constantly make updates, not only to improve it, but just to make sure that it doesn't break. And that's just something that Bitcoin is not really doing.
Okay, and then so something you called, and forgive me if I get this wrong, you called it a coin joint.
Yes.
Yeah, okay. And there's that, but this Wasabi solution, it's different. It doesn't use.
No, this is the coin joint.
It is.
Yeah.
Ah, okay. Because yeah, the concern that I have that it just seems too complicated for typical everyday use. But I think based on what you're saying, every kind of transaction or the vast majority of transactions should have this kind of privacy. So this needs to be solved, I suppose.
And it's automated. Like the software does this. For you as an end user, you install Wasabi, you click on receive, you write down your 12 words, right? Creating your wallet. You click receive, money comes in. You click X on and close Wasabi. Next time you open the wallet, it will say 100% private, and you have anonymous coins that nobody knows are yours.
So it's easy from the user perspective. Okay.
And that was like the main quest of Wasabi throughout like 3 major iterations. We automated more of the system. We made it much more private and especially cheaper. And eventually with like version 2.0 in 2022 or something, we got it to a point where it was so cheap and so private that we could just turn it on by default for everyone. And it costs you almost nothing and 0 user interaction. Right? So this can be solved on the wallet level, even without any user cost or very little. But then how do we get every other wallet to it? And that's where it's not more difficult. It's where we found it.
Every other one, you mean every other
wallet, yeah.
wallet?
Yeah. And then also the one downside, for example, was that Wasabi only works on the laptop. Right? Wasabi does so much magic in the background, like your phone could not handle it, especially iPhones could not handle it. And so there's real trade-offs of you need to have a proper computer where you can do actual stuff in the background, where you can spin up like 24 identities in parallel and like all types of crazy shenanigans that a regular phone just, the operating system doesn't allow you to do.
I would
So
say
Max,
on a user,
there is a. I'm sorry. Go ahead.
just on a user level, I think what lots of people do for their privacy is they kind of separate their stashes, and they do have like operational money. So they have like play money in a, maybe hot wallet that they daily pay with. They do have more secure money in proper self-custody solution. And also people that live on Bitcoin completely, they buy fiat. So what they do is if they need to do some transactions that, still are not ready for crypto, they actually buy fiat, pay it with fiat, and keep their stash private.
Yeah.
Then it obviously comes down not just on the self-custody solution privacy, but you also have to be aware of connecting your real life persona to your wallet. So if you are buying in exchanges, then you in 99% have to go through a KYC process. And so basically anything that you acquire through an exchange now is completely directly linked to your persona, and therefore also to your, social security number, or, your identity, physical identity.
Yeah, exactly. Like this is basically called compartmentalization, where it makes sense for a lot of operational security. Basically have a need to know principle, and different people know different things. And the basic example is you have a work computer and you have your personal computer, and you keep them separate. And a lot of people do that. Same concept applies to your wallets as well. You can have one wallet where you have your KYC stack that you bought on an exchange. Then you have a separate wallet, maybe on a separate computer or separate hardware wallet, right? Where you have the coins that you earned for, selling pizza or whatever peer-to-peer trade. And you can keep them separate this way. And this works. The only problem is that once you make a link between these two, it might be catastrophic loss. And that's where like using coin joins, for example, helps, because it has much stronger separation guarantees than just having separate wallets and so on. Yeah.
It's a little bit more like if you have a checking account and a savings account and you keep them separate.
Yeah. Oh yeah, and this is also not just interesting for privacy, this is also interesting for safety, right? And security. Like you want to have a little bit of money in your pocket so that you can buy the coffee on the road, right? But you don't want to have your multi-generational wealth and the phone with you, because you might lose the phone, someone might steal it, someone might take it from you as it's unlocked, and then all the money is gone. And then you also want to occasionally top up the money, right? And so maybe you have a couple $1,000 on a hardware wallet sitting at home, which you occasionally every once a month or something send money to your phone from the hardware wallet to your phone. And then your actual long-term savings, where this is for your grandkids, you're never going to spend it unless something crazy happens. Then you can have your 2 out of 3 multi-signature with 3 different hardware wallets in different jurisdictions, and you have to fly to the places to get it. And that makes sense, right? Because if it's difficult for you to spend your money, it's difficult for the attacker to steal it. It's easy for you to spend, it's easier for the attacker to get it. And so having that separation makes a lot of sense, both for privacy and just security.
In fact, historically, what you said before, Matt, has been almost a rule when we speak about the times of the silver standard or gold standard. We call it that way because at the highest level was gold or silver, but that was not the money. People were not spending silver; they were spending copper, and they kept separate processes for each of the different. You look at the life of a merchant in the 16th century, and the systems and the processes of each of the different metals was different. They were for different purposes. So it makes a lot of sense what you were saying on the connection in terms of processes that you were pointing.
Max, I have a question, a couple of questions. The Wasabi wallet, there's an iOS app now. It looks like that's a hot wallet only.
No,
If you
sorry,
want to use it,
that doesn't
go ahead.
there's no iOS wallet. Either it's a scam or just something completely unrelated.
Wow, really interesting because it links to your website. I mean, you probably ought to talk to the Apple store
Okay.
because it allows you to create a wallet. It creates the seed phrase. I mean, it looks very, very legit. Shows ZK Snacks as the developer. Anyway,
Looks like a scam because ZK Snacks also doesn't exist anymore.
Anyway, interesting. Okay. Good to know. So on the wasabiwallet.io website, there are downloads for like a Mac and Windows, etc. Are those legitimate?
Yeah, wasabiwallet.io.
.io, correct. Okay. Those can be matched with a hardware wallet as well, right?
Yes, but
So
unfortunately not for the CoinJoin.
It doesn't work for the CoinJoin, you're saying?
No, because that's super hard, and actually only Trezor did the heroic effort of implementing that. And I'm not sure if
And then they took it right back out after the samurai guys got arrested.
exactly.
And it was the best implementation, by the way. I studied all of those a few years back. I tried all of them, every single one. And they really had the best implementation at the time in terms of the user experience.
Yeah.
So what would you recommend? And going back to my original question where I have this customer now and I have two businesses that are going to be accepting Bitcoin on a regular basis and paying in Bitcoin. What would be, to kind of wrap up all these things we've talked about, what would be the best practice to use because it sounds like CoinJoin is a good solution, but how do I access it? I guess is my question. And right now I'm set up with Trezor wallets and I'm running Alby Hub on Lightning, which is a whole nother story, but maybe that's probably another seminar we don't have time for today. But and if I just talk about on-chain payments, what would be the best practices kind of take away from this that are easy to implement?
Yeah, so I think basically you will have for your company treasury, like the savings account, your hardware wallet, maybe a multi-sig among your business partners. Right?
Yep.
And once a month, once a quarter, you send the payroll amount that is needed to a hot wallet in Wasabi. And you make a round of CoinJoin, and then you initiate the payments that you need to do inside of CoinJoin. That I'm not sure. I don't think it's yet in the user interface, so you need a little bit of command line magic for that. But hopefully in the next release, that's in the UI as well. But then you can basically send, okay, this address gets this amount, this address gets this amount. You add your 5 addresses or however many that you need to do, and it does the CoinJoin, and within 1 or 2 transactions, it will make the 5 payments. And nobody knows that this was a payment in the CoinJoin and not just your own making the transaction to yourself. None of the receivers know your input, so how much money you actually have. And none of the receivers know the outputs that the other receivers got. They don't know the salaries of the other. And so this is.
So could you almost do that? What I'm hearing is you almost set up a best practice where if you're going to make payments, let's say twice a month, you're going to pay bills, pay employees, pay whatever. You just run through that same process. So you make one deposit into the Wasabi wallet on the desktop, CoinJoin all of that, which mixes it all up, and then I release the payments to all of my suppliers, my employees, etc. And what I've done is protect myself from exposing to them the original wallet. So only my customer knows the wallet where they sent my money, so they can in theory look at my revenue. But if I'm generating a separate wallet address every single time, they can only see their transaction. And so really on the payment side, that's where you just put the Wasabi wallet in the middle.
Exactly.
And even though that's a hot wallet on my computer, it's very short term. I'm not storing funds in it. I'm just using it transactionally to do that. Okay. And then the other thing is I've researched about CoinJoin. Yeah, go ahead, Christina. Sorry.
I would also look into BTC Pay, setting up BTC Pay server. because you can actually have your customers upload invoices directly into that. It gets kind of automated.
Yeah, so what we're doing on that, we're actually working with Pierre and the Get With or Pay With Flash guys. They've created a new treasury thing that's similar, but it also integrates with credit card processing, which is why we're using it. Because some of the customers will pay with credit card, and then we can convert that to Bitcoin, kind of like Square does. But because BT Pay server is only on the invoicing and receiving side, correct?
Pay server also can. I'm not sure if that's the name, but that works.
I'm sorry, you broke up a little bit, Max. Can you say that again?
The Pay server can also do Bitcoin buying.
Oh, it can. Okay, I'll look into that. Interesting, because I was with Echo Rockstar at a conference a few weeks ago, and we talked a little bit, and I didn't walk away with that use case in mind after our chat. So interesting. Okay, and then there was another follow-up question I had to that, and I've forgotten it now. This has been really insightful. I'd love to have a follow-up and talk about Lightning.
Yeah, we haven't touched on that at all, but Lightning is also a very good solution to the privacy.
Yeah.
There are basically two overarching solution types for Bitcoin privacy. The first is a conjoin. So we all put our transaction history together in one focal point, and then all the transaction histories go out again, and we lose track of inputs to outputs in that focal point. That's the conjoin. The other solution is the coin swap. You have a coin with a transaction history in that direction. You have a coin with a different transaction history in that direction. Now you swap the coins. You get his transaction history. He gets your transaction history. And if we do that often enough, then transaction histories are meaningless because you never know if any transaction was a swap or just a payment. And Lightning Network is a coin swap network, basically. But does it off-chain, not on-chain? You can do coin swaps on the blockchain as well. And so Lightning Network takes that into the second level. Yeah. But very, very interesting Lightning. It's covered in that thing as well. Chapter or something.
Yeah.
Lightningprivacy.com. Maybe also then a small note of like why Wasabi Wallet doesn't have Lightning, because we created really, really good privacy guarantees for Wasabi and Bitcoin blockchain transactions. And then when we thought about adding Lightning, we couldn't achieve the same guarantees as Lightning. Like Lightning has the potential to be very private. It does need a whole bunch of engineering work to actually make it so. And we never really did that engineering thing. So there is no easy solution of just use Wasabi for anonymous blockchain transactions. I don't think the same exists for Lightning. So if you do want to use Lightning privately, it does require you to do a lot of customization.
What is the cost for coin join coordination within the Wasabi Wallet desktop apps?
So basically just blockchain cost. Which depends then heavily on how you use it, but ultimately the traditional coin join is a transaction where you send the money to yourself. And so you have your 4 inputs, your 5 outputs, for example, at like 1 sat per gigabyte, that's maybe 500 sats, so like less than $1. If you then make a lot of transactions yourself, then that increases the fee compared to the actual payment. But because you can make a payment in the coin join as well, and then you can batch payments together, like if you need to pay 10 employees, in theory, you could do that in one transaction. And then you have like your 1 input, your 13 outputs, 10 goes to your employees, and 3 is the breakdown of the change. That's extremely efficient. Way more efficient than if you would manually make every transaction yourself.
So how does Wasabi Wallet monetize its work today? Because it was charging coin join fees or coordinator fees before, right?
Exactly, yeah.
And
So that my company, CK Snacks, that you mentioned earlier, we had a 0% fee. But we shut down the company. Other people jumped on to do the coordination, and they just chose to not do anything. So there is a little increment, like a leftover dust almost, that gets given to the coordinator. But yeah, it's negligible.
It's insignificant in terms of the value created by using it.
They're less than 1,000 staff or something.
Okay.
Depends on the details, but yeah, no, you can donate.
Yeah. Okay. So what do you do now? Are you still with Wasabi Wallet, or are you doing something else?
No, I moved on. Like I basically consider the money privacy problem solved with Wasabi. Like Bitcoin is anonymous now, you just need to know how to use it.
Yep.
There's other things that need to be doing. So right now I worry about anonymous communications. Right. So how can we as a group of people coordinate and communicate, have a chat basically, without any trusted third party and without leaking metadata? And so decentralized anonymous group messaging, basically. And that uses Nostr. And the encryption scheme is the messaging layer security protocol, MLS. And we combine the Nostr protocol and the MLS protocol into a new protocol that we call the Marmot protocol. So these furry animals. And the app that does that is White Noise. So we're working on the protocol first, and then White Noise is the app, and there's like another app that supports the same protocol now as well.
Super cool.
Yeah. Any question?
I have to run to another meeting, but this was a great seminar, great session. Really good. Thank you.
Oh, microphone.
I would invite you. Oh, you're gone. So no need. Okay. If there are no more questions, I think those who are here, we can have a coffee or food or whatever. I think you still have some work today, I heard. And perhaps some hiking in the mountains later. Good. Thank you all for coming. Thank you, Matt.
It was a pleasure.